Hi, good morning to everybody. My name is B.K. Pandya from the Business Communications. Today we are going to discuss about the benchtop turbo systems and the process which we are going to use. This is called the evaporation systems. Throughout our training, we are going to discuss about what is the thermal evaporation process. Then which type of the evaporation is used in the industry, and the brief about the filament, because there is some limitation. We cannot use the all material as a heating filament. Then there is some limitations. And next about the systems, hardware, controls, display, hardware architecture we have to discuss. And the next important sensor is called QCM. Like we are going to control our evaporations by help of this QCM, this quartz crystal monitors. We are going to discuss throughout our training. First, we need to understand what is the evaporation systems. Evaporation system is the process where we are giving the energy to the material like aluminum, silver, and the different material under the low vacuum conditions. If you are giving, suppose I am putting here the one material and I am giving the heat energy to a material inside, there is low vacuum conditions. After that, this material, it will be moved from down to top directions. For that, we are using the vacuum pump, and the systems we have to create the low vacuum conditions. After that, here this is the heating element, and according to the system configuration depend how much heat energy we are going to apply to our material. And about the system, what is the application and where it's using in the real life. Generally, in the evaporation system is used for the fabrication technology. For the micro fabrication is used in the real life, and the thin film it's used in the real life. Okay. If you talk about what is the physics behind it, then there is some formula, and many people doing the research under the low vacuum, how the physical activity is working. Suppose I am giving the heat energy to the any material, how they are going and developing the one thin film layer on our substrate. For example, we are making the one bale jar, and downside I am putting here our material, and this I am considering that this material is under vacuum. Our standard vacuum condition we are using 10 to the power minus 5 torr. Then there is the standard formula. The formula is mentioned here, and all constant I have already mentioned what the parameter we are using during for the calculation if you are doing the process under the vacuum conditions. Next, about the type of evaporation. Generally in industry, thermal evaporation can be categorized in the three parts. One is called the filament evaporation. Second part is called the E-beam evaporations, and the third is called flash evaporations. Now we have to discuss about the thermal evaporation process, because our system can do the only two process. Either it will be thermal evaporation process. Excellent. Here we are going to discuss about the filament evaporation process. In this process, we are using the one electrical filament, and our system range we are going to apply from 1 kVA power to 2 kVA power. And on the filament, we are applying some material. Either this material it will be like the silver, it will be aluminum, and many more. I have the list in the next slide which kind of material we can use. In the E-beam evaporation systems, this is the another technique, but this technique we are not going to use in the system. Just this is the only technique in other technology, like the other equipment. Some people is using for the E-beam evaporation process. The process is different. What the process about this one? We are using the material, but we are doing the bombarding of the electron on the material. Then under the low vacuum, this material move from the target and going to the substrate. Downside is the another technique, the flash evaporation process. But we have to only discuss about the filament evaporation process because our system is only capable about this first technique.
So our system is only filament
There are
evaporation.
two processes. I will discuss two processes. One is called the TCS sputtering and the other is called the filament evaporation process.
And this system is equipped to
This equipment can do the two processes.
Okay.
Yeah. Okay. Now we have to discuss about what is the electrical filament. In the electrical filament, the recommended part generally we are using this kind of filament, and the third company which the professionally they are making the different kind of filament. It's online available. You may order from there. Either you may make your own filament, but what is the problem? If you are making the own filament, then there are two, three complexity to calculate, because if you are making the own filament, then you have to decide what can be the sustainable power for this one and at what maximum power we can use. Suppose I buy the online this filament, then I have the detail what maximum power I can apply, because we know our system ranging from 1 kVA to 2 kVA. Suppose I suddenly apply the 2 kVA power there, then it will be within few seconds it will get break. That we ordered online this standard the filament, and the material which you are using is called the tungsten molybdenum. Generally this two material is using for making the filament. If you are going for the other materials, because I remember last time I tried to make the filament by help of the copper wire, but the copper wire it was not more successful because the copper had the low melting point. Before melt your sample, it will get melt and the circuit will get break during the process. Next, about the filament evaporations. Here there is some list of the material what the people in the other lab they are using this kind of material for making the substrate coating, like it should be the aluminum, silvers and many more. And the second point, this is the deposition rate, the standard the people they are using from 1 to 20 angstrom per second. And the next point, we are expecting during the process, they can go the temperature 1800 degrees. And they are talking about the material cost. There is not more expensive materials. But if you discuss about the other material for the evaporations, the cost wise they are more expensive compared to these materials.
So these materials are used for filament, or these materials will evaporate?
This material you have to evaporate. Yeah. For the filament, this is the tungsten and this material we can use. And even I order for you like the spare parts I can give to you. This is this kind of how the physically it look like the filament. Next, about the filament. Suppose I am using, this is some range. Suppose we are using the tungsten, titanium and molybdenum, then this is the melting point. This is the high melting point compared to the other material. That is the reason the people is using this material to making the heating filament. And the third line is given the pressure range. Suppose we are working in the 10 millitorr, then we are expecting that this temperature they are going to achieve, because the pressure and temperature according to the gas law they have the own relation. Some the pressure developing and temperature is getting changed according to the principles. Okay, I took some images from the Indian Institute of the Science and the other institute from the plasma research. The people they are doing the research in the thin film coating. Then after making the deposition, we require the different equipment for characterizations of your samples. Either you can go for the TEM, this is called transmission electron microscopy, which is more expensive. Either you can go for the SEM, scanning electron microscopy. As the third condition, we can for the material analysis, we can go for the AFM, atomic force microscopy. In the atomic force microscopy generally is using for the STM concept. STM is a scanning tunneling microscope, and we are making this kind of atomic resolutions, because except this 3-4 device we cannot use the other device. This is the some examples how after depositions look like. Next, this is the small theoretical background which we already discussed. Now we have to discuss about the thermal evaporations, the system which we are going to use after the presentation, which we are going to make the practice on the systems. The system exactly look like that. Here in our next slide I will discuss about the all hardware part, and this is the first view of our systems. Next, if you are talking about the system specifications, then it's made by the Denton Vacuum Company from United States. The second point is called the working chamber pressures. I said in my first slide that we require the vacuum condition inside the chamber. Then for the system, they are recommending the manual to use the 10 to the power minus 5 torr or less vacuum condition inside the working chamber. But I saw in different labs some people for the different material they are using the 10 to the power minus 6 also. But in the manual they have mentioned just use 10 to the power minus 5. Yeah, we can. Yes, we can. We can use the 10 to the power minus 5 torr. Yes.
How much is it?
Yeah. We will discuss it. It will take the time. That is the more disadvantage of this technology. Next, about the filament power rating, because all company have their own power rating, like this, and also depend on your research equipment, which kind of research and what material you want to develop. For our system, we can use either 1 kVA and 2 kVA power for our systems. This is called the filament power. Next, about the substrate side. Generally in the substrate, the people use as a glass substrate, silicon substrate, and the many more. It's like depend on your research what you want to do. Then filament, like the substrate size, you can go up to 8 inch of the size. Either it will be a small also. Next, deposition control. The one more challenge here, because we know that if any material continuously traveling from down to top, if you are not make the proper controlling, then after some time the nature, the deposition, it will become like a parabolic on your substrate. For that we require to control we require the second controller to control this process, so that we can get the uniform layer on your substrate. If you are not able to get the uniform layer on your substrate, then the many disadvantage we can get during when we are making some research, we are going to use for the fabrication technology. For that, we are using this SQC310 controller to control our process. I will discuss briefly in the next slide how this SQC is working under the vacuum conditions. Next, about the substrate SP. As I said, if you are keeping the substrate as a constant, then the material, it will be deposit like a parabolic. For controlling this one, we rotate our substrate with the constant SP, so that the distribution of the material it's become the uniform for our substrate. Then our system range, it can be go up to 0 to 20 RPM. Next, about the substrate temperature. We know that suppose under the vacuum conditions we are heating the one substrate, and substrate is traveling from down to top, then we are believing that they will transfer the heat energy to your substrate. Then expected your substrate can also get heated near about 300 to 400 degrees C. In between this temperature, your substrate will be receive this temperature, because the downside material, they have the high temperature.
So the substrate is heated, is just the heat coming from the material.
Coming from the material, and their material is transferring the heat to the substrate. because here I just put the limitation. Suppose if you are using some material, they have the limitation to melting point near about, for example, they have the 100 degrees C, they have melting point. Then we start doing this process. Before coming the layer, they will be melt and it will fall down.
Just local heating. Just local heating.
This is the local heat is coming into the process. Yes. Next about we have to understand here how the chamber is look like that, and exactly same we are going to find the same material, same hardware part inside. If this is the glass chamber, and in our terms we call the bale jar. It's look like it is the shape in the U kind of shape they have, and it's the transparent glass. We are able to see internally what's going on, because in the evaporation process, if we are giving the heat, then the material is turned to the red conditions. Sometimes it's not recommended to look continuously inside the process chamber because it's not good for our eyes, our retina. For that, this is the glass chamber, and the advantage about this one, we can understand like this process is going on inside. Suppose this is not transparent material, then suppose I by mistake, suppose the filament is got break during the process, then we are not able to track they are doing the process or not. Then this transparent glass is the very important. This is called the bale jar. Next, about in the top side we are going to put the substrate. The substrate size can be up to the 8 inch. Here we are going to use the substrate in the top side of the substrate. Next, for the substrate